Hi, my nursing friends. So today we're going to go over IV calculations. And with IV calculations, don't worry, they're not hard at all. They're pretty easy. I mean, like when I first started in my Med-Surg 2 class, I was like so confused. But we're going to start simple and then we're going to go on to harder problems. But the basic things that I just wanted to quickly talk about is with IVs, you want to know when you're going to start and stop your IV administration and at what rate you're going to infuse, let's say medications, fluids, or I don't know, like nutrition or whatever it is. And you also want to know how much you're going to give. So with that said, let's get started. So before we start, we're going to just quickly, briefly talk about formulas for IV calculations. These are really simple and it's just a quick way for you to find out what you're looking for in these problems, and it's going to make it much easier. So when we're looking for ml per hour, what that basically is your total volume over the number of hours you will be infusing. So for example, in the problem it will, give 2,000 ml is being infused over 12 hours, something like that. So that's just one example. The next one is your number of hours. Maybe they're going to ask, how long is this going to infuse for? So what you're going to do in the problems, you're going to take your total volume and you're going to divide that by ml per hour. So basically, you're going to need this to find this, and you'll see that in our problems. The next one is gtt per minute, which is basically drops per minute. And in order to find that, you're going to take your ml over minutes multiplied by gtt per ml. And usually they'll give the calibration. This is what it's calibrated to. For example, they might give like 10 gtt per ml. It's most likely given in the problem, multiplied by ml per minute. Now with ml per minute, you're going to need your ml per hour, right? Because there are 60 minutes in 1 hour. So it's, very easy to use that in this ratio. So then if we have ml per hour, all you have to do is just erase that and put 60 minutes or whatever it's given in the problem, and we'll figure that out. So let's get started. So in this problem we have an IV of 600 ml is to infuse in 3 hours. Calculate ml per hour. So we're going to take 600 ml because that's our volume, and we're going to divide it by the number of hours, which is 3 hours. And we're going to take our calculator and we're going to take 600 divided by 3, which is 200. And ml per hour. And there's our answer. An IV of 2,000 ml is to infuse in 12 hours using a 10 gtt per ml set. Calculate the gtt per minute flow rate. So my first thing before I even go on with the steps of what I need to do is, what are we looking at here? We're looking at gtt per minute. So that's what we're trying to find. So I'm going to write down here, gtt per minute, which is basically drops per minute. Now, my next step is figuring out how many mLs are we infusing in just 1 hour, right? So let's do that first. So step number 1, we're going to find out how many mLs are we giving in 1 hour. So we're going to take 2,000 ml divided by 12 hours. So that will equal to, take your calculator, 2,000 divided by 12 equals 166.6, and it just keeps going on. So in this case, we're going to round to the nearest whole number. So because this is greater than 5, it will be 167 ml per hour. Okay, so we got that down. Put a box around it, make it special. Okay, next we have our calibration. This is what we're calibrating it by, drops per ml, 10 drops per ml actually. So we're going to take 167 ml per hour. Now instead of putting hour, look at what we're trying to find right here, minutes, right? So we're going to have to switch hours to minutes. So how many minutes in an hour? That's right, you got it, 60. I mean, last time I checked, it was 60, but all right. 10, we're going to use this information that we have because we have to multiply it by the calibration. 10 drops per ml. Now you're thinking, okay, why are we doing this? You're going to find out in just a second. We're going to multiply this straight across, okay? And by doing that, our mLs are going to cancel out and we're going to be left with drops per minute. And that's what we're looking for, right? I know, it's magic. Everyone's going to be happy. Okay, so we're going to take our calculator and we're going to multiply straight across, okay? And then we'll divide. So 167 times 10 divided by 60, which gives you 27.833333, keeps going on. So again, we're going to round to the nearest whole number, and because 8 is greater than 5, it's going to be 28 drops per minute. Yay! So our next question is quite similar. A volume of 1,250 ml is to infuse in 12 hours using a 15 GTT per ml set. Calculate the GTT per minute flow rate. So again, we're looking for drops per minute. I'm going to write down the bottom. That's what we're looking for. And my first step is, remember, 1,250 ml divided by 12 hours, because we want to find how much are we giving in 1 hour. So I'm going to write that right here. Take my calculator. 1,250 divided by 12. So we get 104.16. And again, we're going to round to the nearest whole number. So because 1 is less than 5, we're going to have 104 ml per hour. Okay. And then our next step is going to be taking that 104 ml per, instead of using hours, we want minutes, right? So over 60 minutes, because there are 60 minutes in an hour, multiplied by our calibration. 15 drops per ml. And then when we multiply this straight across, mLs will cancel out. And let's see what we get. 104 times 15. Divide that by 60. And we get, ooh, perfect number, 26. And I'll write that right here actually. 26 drops per minute. Yay! Okay, moving on to a harder question. An IV of 2,000 ml has been ordered to run over 16 hours. Set calibration is 10 GTT per ml. You start the infusion at 0800, and that is military time for 8 o'clock in the morning. And we want to know what is the infusion time and what time on the clock will the infusion be done. So, what is the infusion time? We know that it's going to be run over 16 hours. So that is our infusion time. That's how long we're going to infuse the medication or fluids or whatever it is. So for the first question, for part A, is 16 hours. Okay, now we're going to look at what time on the clock will the infusion be done. Now, when you guys go to clinicals and things like that, you're going to see that everything is in military time. I know it sucks. You got to get used to it. You got to know it. But it's not that hard to get used to. So we're going to take 0800. This is a way easier way to just calculate all of it out. So we're going to take 0800 plus 1600, just like that. And we're going to put that on our calculator. So 1600 plus 800. Whoopsies. Why is it doing that? Equals 2400. And that is midnight. So that is the time on the clock that the infusion will be done. So now we're going to figure out what is the flow rate by IV pump. And basically what that means is our ml per hour. They're just trying to trick you with this little wordage. But we got this. No tricking here. Okay. So we're going to use our volume, 2,000 mLs. And we're going to divide that by 16 hours. Which will give us 2,000 divided by 16, 125 ml per hour. So now we're going to figure out what is the flow rate by gravity. And flow rate by gravity basically means drops per minute. Okay? So if you can remember in our previous question for B, it was 125 ml per hour, right? I'm just going to write that right here because we're going to need that. So we're going to use 125 ml. And remember hours, we need minutes, right? Hours to minutes, which is 60 minutes in an hour multiplied by our calibration, which is 10 gtt per ml. Because we're looking for drops per minute. So again, I'm going to write that over here one more time. So mLs cross out, right? And we're going to multiply across 125 times 10 divided by 60, which is 20.8. 3, and it keeps going on, 3. So that would be rounded to the nearest whole number, right? 21 drops per minute. Okay, this is a little bit more trickier, but I think you guys can handle it. So we have an order of 1,200 units of heparin every hour IV continuously. The solution is 35,000 units of heparin in 1 liter D5 half normal saline. Start at 0800 with a drop factor of 20 gtt per ml. What is the flow rate by IV pump, which we talked about earlier is ml per hour? Okay, so first we're going to take 1,200 units of heparin, which is given every hour. So I'm going to put that over hour. I'm basically taking everything that's given in the question and making it into proportions to see what I have and see what I'm going to use. And we have a solution of 35,000 units of heparin in 1 liter, blah, 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 right? And we're starting at 0800. We don't really need that right now. And drops, we don't really need this. So this is what we're given, right? And remember, what we need is ml per hour, right? So we have hours right here. That's already given. All we need is mLs. In order to get that, we have to look at this proportion right here. We have 1 liter. So we know that 1 liter is also equal to 1,000 mLs, right? So there we go. We have ml now. So what I have to do with this proportion is flip it, right, in order to get ml on the top. So I'm going to write that over one more time. Units over 1 hour. Multiply that by 1,000 mLs over 1 liter, or what am I saying? 35,000 units. You guys are like, what? Which is equal to, and obviously these units are going to cancel out. We're going to get, multiply across, 1,200 times 1,000. Divide that by 35,000, which gives you 34.28, right? So we know that 2 is less than 5, so we're going to keep it at 34 ml per hour. Yay! So now we're going to look at what is the flow rate by gravity. Okay, and that basically means drops per minute. So what we're going to need is our information before, which was 34 ml per hour, right? And we're going to have to use our calibration, which is 20 drops per ml, right? Because we need drops per minute on the other side. So we're going to obviously switch the hours to minutes, 60 minutes in an hour, right? And we're going to multiply this. So our mLs cancel out, and I'm going to take my calculator. 34 times 20 divided by 60, which gives us 11.33, and it goes on. 11.33333. So remember, 3 less than 5, we're going to keep it at 11 drops per minute. So now we're going to figure out what is the infusion time to the nearest minute and what time on the clock will the infusion be done. I didn't have enough room to write that, so I just put clock. So our first step is finding out what is our volume, how much are we infusing, and that is right here. It's 1 liter, which is also equal to 1,000 mLs, right? And if you remember in the beginning of the video, I gave a formula to find out how many hours will something be infused in. So that was the volume divided by our ml per hour. And remember, our ml per hour was 34, right? ml per hour. So we're going to put that in the calculator. 1,000 divided by 34, which is equal to 29.4. 29.4, and it goes on. So because 4 is less than 5, we're going to keep it at 29, and this will be hours because the mLs will cross off. So we know that our infusion time is 29 hours. However, now it's asking to the nearest minute. So we actually do have to look at what is after the 0.4, right? Because that doesn't mean 40 minutes or anything like that. So 29.41, right? So we're going to look at the tenths and the hundredth spot. So we're going to take 0.41 and we're going to multiply that by 60, right? Because there's 60 minutes in 1 hour. So take our calculator, put 0.41 times 60 equals 24.6. And then 6 is greater than 5, so we have to round up. So it would be 25 minutes. I don't know if you guys can see that with my camera. Ooh, Let's bring this down. You guys see that now? 25 minutes. How I got that? 0.41 times 60, which we get 24.6, which equals 25 minutes. We got to round up, right? So that is to the nearest minute. So now we have to figure out what time on the clock are we going to finish. So let me just erase this real quick. Okay, so we have 29 hours and 25 minutes, right? So we know that we're starting at 0800 plus 2900 plus, it's all about those zeros with military time, right? It just makes it easier for you guys to, you know, get the hang of this, and then after that you don't have to do it like that. But, so we have 0800, right? That's what time we're starting. 29 hours and 25 minutes. Now 29 hours, we already know that 24 hours is in a day, right? And this is over a day. So we're not going to add all of it up. Instead, we're going to subtract 2400 from this, so that gives us an easier number and easier stuff to work with. So we already know that it's been one day, right? So we can go back to our calculator. 800 plus 500 plus 25 equals 1325. And that is the time on the clock that we will finish our infusion. So I hope this helped you become more comfortable with IV calculations, and if you're still not, that's okay. Just practice these problems over and over again, and I promise you, you will get it. You will see the light at the end of the tunnel. I promise you will. So if you guys need any help, just message me at facebook.com/Verona004. All right, bye guys.